Hello, today we're going to be working on lesson 5.3, which is an introduction to sum and difference formulas. In this section, we're going to be using formulas that involve sums and differences to find values of trig functions that we don't already know from the unit circle. So for example, right now, if I said, hey, what is sine of pi by 3? You should be able to give me that answer without the use of a calculator. However, if I said, hey, what is sine of pi by 10? That is not something that you're going to know because it is not a common radian value. Therefore, we don't have it memorized, right? Pi by 3, pi by 4, pi by 6 are kind of, and their counterparts are sort of like what we've memorized in the unit circle. It's impossible to memorize all of, the possible answers. So instead, what you'll be doing is using sum and difference formulas. Okay, now sum and difference formulas are these guys here. Obviously, they look quite intimidating at first glance. And that's probably because Greek letters are used instead of thetas, like what we're typically seeing with cosines and sines and stuff. But all these are just formulas that take you from one side to the other, or this, they work both ways, but it just allows you to find uncommon angle measurements. So let me show you an example. This is a very abstract question. The purpose of this question is to help you understand the formulas, so that's why we're doing it. So if I said find the exact value, meaning no calculator, find the exact value of cos 70 degrees, cos of 40 plus sine of 70 times sine of 40. Okay, that is not something you're going to know. You don't know cos of 70 and you don't know cos of 40 and so on, because these are not unit circle angle measurements. However, what you do know is all these sum and difference equations. So do you see how we have cos times cos plus sine times sine? Look at this equation right here. Do you see how this equation has cos times cos plus sine times sine? Okay, here's the other thing that's important. This angle matches this angle. So we'll call those both alpha. And this angle matches this angle. So we can call both of those beta. Okay, so that means that I can apply this sum and difference formula to help me solve the problem. So it says cos of alpha times cos of beta. Okay, we have that. Plus sine of alpha times sine of beta. We have that. What is it equal to? It says it's equal to cos of alpha minus beta. So this is all equal to cos of alpha minus beta. And that's just according to those formulas. And we can do a little bit more from here because we know that alpha, we said alpha is this first angle, so that's 70, and beta is that second angle measurement, which is 40 degrees. So basically what I'm telling you is that this whole long complicated equation is essentially the same as finding cos of 30 degrees, okay? And I wouldn't know that if I did not know about this formula here. So once you apply the formula, then you can just use your unit circle brain power to answer the question. So what is cos of 30 degrees? That should be radical 3 over 2. Okay, let's try a few more like that. So what is sine of 22 cos of 13 plus cos of 22 sine of 13. Okay, we don't know, obviously. We don't know sine of 22 degrees, but we do know that this angle matches this angle, so we can call those alpha. And we know this angle measurement matches this one, so we can call those both beta because they're the same. And we need a formula, so we got to go back to our list, find a formula that fits this pattern. Sine, cos, plus cos, sine. Sine, cos, plus cosine, right up here. Okay, so once we find the correct formula, we are going to then look over to this side here, and it says all this stuff is equal to sine of alpha plus beta. All right, let's try to write it that way. So this is equal to sine of alpha, which is 22, plus beta, which is 13. Add those two together and you get 35 degrees. Okay, now for this question, it says write the following expressions as the sine or cosine of an angle, meaning you would stop right here because that actually is not something that you know. So the purpose of these questions is just to choose the right formula and kind of practice with them. Okay, so next one says pi by 3, so that matches this angle here. So those can be our alphas because they are the same. And we have this angle matching this angle, so those can be our betas. And we need to choose what formula. So this is a cos plus sine. So go to your list. Cos plus sine is the one we used in our first example. That is equal to cos of alpha minus beta. So let's go back and let's set that up. So that's going to be this equals cos of alpha, which is pi by 3, minus beta, which is pi by 4, and you're going to subtract. Okay, now I'm going to ask you to do something, and you're going to think I'm the meanest person alive, but I'm going to ask you to subtract fractions without a calculator. Okay, without a calculator. You can do this. Common denominator is the name of the game with subtracting fractions. So I'm getting a common denominator of 12, multiplying the top and bottom by the same value. And you're pretty much done. Once you have that common denominator, you can subtract the numerators and you should get pi by 12 for that. And again, remember, this is not something you're solving because the directions did not say to solve. All right, let's use these formulas in a different way. So it says find the exact value for cos of 15 degrees. Okay, that is not a unit circle value. Now they're giving us a hint right here. And they're saying, hey, guess what? Cos of 15 is the same as 45 minus 30. Well, duh, we're not stupid. We know that 15 is the same as 45 minus 30. Why the heck are we writing it like that? Well, that's because if we write it as something familiar minus something else that's familiar, meaning I know these unit circle values, then I can apply a difference formula to help me solve this question, okay? So what I'm going to do, make a little bit more room, but I'm going to say 15 is equal to 45 minus 30. Then I can establish that 45 is going to be my alpha and 30 is going to be my beta value. And I'm going to go back to my list and I'm going to look for cos of alpha minus beta. This one, I guess we keep using this one, don't we? This fourth one down. It says this cos of alpha minus beta is equal to cos of alpha, cos of beta, plus sine alpha, sine beta. So how does that look for us? That looks like this. Cos of 45 degrees, cos of 30 degrees. That's your cos alpha, cos beta, plus sine of 45, sine of 30. Okay? So all of these things are equivalent. Looks like I'm making the problem harder, and I kind of am. But the purpose is to be able to solve all of this without a calculator. Okay, so let's go through. Cos of 45, that is radical 2 over 2. Cos of 30 is radical 3 over 2. Sine of 45 is also radical 2 over 2. That's a 2. And then sine of 30 is 1/2. Multiply, so top times top, bottom times bottom on both sides. And you could stop right here because there's not really a way to combine these nicely, or you could, if you wanted to, go ahead and add the numerators together and put it all over one fraction. But either one is your solution. Okay, so let's apply these formulas in a property manner. So this is like your trig proofs that you did in 5.2. Remember, the goal is to make the left side equal the right side. So we're going to start here on the left. And we're actually going to start at the very top and change the top to a difference formula. So you're going to go back to your list of formulas, and I think it's that fourth one down again. We keep using the same one over and over again, but change the numerator of your fraction into the sum formula, which is cos of alpha, cos of beta, plus sine of alpha, sine of beta. If you wanted to, by the way, you could just change these to x and y or a and b if it's easier to write. Okay, so once we get to this point here, what we can do is we can actually decompose this fraction because the bottom is all one big term. So decomposing fractions means that you would break this up into two fractions. So you would put cos alpha cos beta over cos alpha cos beta. That's like the first fraction here, plus sine alpha sine beta over the denominator cos alpha cos beta. Okay, so what does that allow you to do? Well, that allows you to look and see if you can simplify anywhere. The second fraction can't really simplify, but over here I can cancel the cos alphas and the cos betas. So that makes that equal 1, which is one of the two things we need. And then this part I can't really simplify. However, sine alpha over cos alpha equals tangent of alpha. Sine beta over cos beta equals tangent of beta. And then we have the equation now is equal to the right side, so we are finished. Okay, same thing here. It says verify the identity. We do have a difference identity, a difference quotient, because this is an angle minus an angle. So we will call pi by 2 our alpha, and we'll call x our beta value. So we need to go back to our list again, and we need to find the one that has sine of alpha minus beta. So here's one we haven't used yet. It's this second one down. It's going to be equal to this equation here. So we're going to write this equation, but everywhere we see alpha, we will be putting pi by 2. And everywhere we see beta, we'll be putting an x, because that's what's given in the problem. So this is going to be equal to sine of pi by 2 cos of x. So that's like sine alpha cos beta minus cos of alpha times sine of beta. And we're trying to make it look like just cosine. So is it possible for this to equal cosine? Well, let's simplify wherever possible. We can simplify these two things here. Sine of pi by 2 is equal to 1. Cos of pi by 2 is 0. And I do think this is going to work. If you look at the simplification, 0 times sine makes all that go away, and that just leaves you with cosine is equal to cosine. Okay, find the exact value. So finding the exact value of sine of 5 pi by 12. Okay, so first of all, 5 pi by 12 is not a unit circle value. So we will be using one of our sum or difference formulas. Now this note is super helpful because that tells you what two fractions that we do know in the unit circle add up to 5 pi by 12. So we already know that pi by 6 plus pi by 4 is equal to 5 pi by 12. So that means that alpha is going to be pi by 6 and beta is going to be pi by 4 in our summation identity. So, or summation formula. So we're going to go back and we're going to look for the formula that has sine of alpha plus beta. That is this first one at the very top. So we need to set up our equation like sine alpha cos beta plus cos alpha sine beta. We need to set it up like all this. But remember that your your alpha and your beta values are already given. So this would be sine of pi by 6, sine of alpha, cos of beta, plus cos of alpha, sine of beta. And look, what you're doing is you're making an equation, a very big equation, but an equation that is equal to each other. So now we're going to solve. So what is sine of pi by 6? Sine of pi by 6 is 1/2. Cos of pi by 4 is radical 2/2. Cosine of pi by 6 is radical 3/2. And sine of pi by 4 is radical 2/2. And then you're pretty much done. Like last time, you're just doing top times top, bottom times bottom. And that could be your answer there, or you can combine it into one fraction if you'd like. Okay, so one more, and then I will go to a different type of question. So one more like this. So we have cos of 7 pi by 12. So you're trying to figure that out, remember, without a calculator. So that's going to require that you use sum or difference formulas. And again, this little note here is super helpful because it tells you that pi by 4 plus pi by 3 is equal to 7 pi by 12. If you don't believe me, you could get a common denominator and try it yourself. But that means that this is going to be our alpha and our beta. So we just need to go find the correct formula that's got cos of alpha plus beta. Actually, I think we haven't used this one yet. So let's go back. Cos of alpha plus beta is this one here. Okay, so it's cos minus sine. That's the pattern. Okay, so we would have cos of alpha, cos of beta, minus sine of each of those as well. Okay, and then we're going to solve. So cos of pi by 4 is radical 2/2. Cos of pi by 3 is 1/2. Sine of pi by 4 is radical 2/2 again, and then cos of pi by 3, that's supposed to be sine. Whoopsie. Sine of pi by 3 is equal to radical 3/2. I feel like we keep getting the same darn answers every time. That is a coincidence. Don't think that's going to happen every time. But when you do top times top, bottom times bottom, you're going to get radical 2 minus radical 6/4.